Okie dokie do. So it is time for us to begin whatever we mean by learning in this new world order. So this is the chain rule lesson, and you have in theory seen the lesson. You have in theory seen all of these problems. You've written this in your notebook. You've worked out how this goes and this goes and this goes and this goes, and you've processed to the best of your ability. I would like to work out the questions that were on the worksheet. So if you have not tried the questions yet, try the questions. Like hit pause, go try the questions, and then come back and watch these get worked out, because you really want to make sure that you can do as much as you can do on your own before you see the quote-unquote official solution. So question 1 here, in the triangle below, theta increases at a constant rate of 3 radians per minute. So what does this mean? This means that d theta dt, radians per minute, that's how the angle changes over time. Angle changes over time. Theta increases at a constant rate of 3 radians per minute. The triangle remains a right triangle at all times. So we've got to talk about at what rate x is increasing. At what rate is x increasing? That means we have to find dx dt. What rate is x increasing? X is increasing over time. So what's the relationship among theta and x and 5? Well, we know that the sine of theta is opposite over hypotenuse. The thing that students tend to do in this scenario is they apply Pythagorean theorem, but you can't apply Pythagorean theorem because that's an angle. So we are definitely interested in something that involves angles, that is trigonometry. So I find it helpful to get rid of fractions. Oh, I'm so sorry. I find that, oh, really? Really? Let's see, that's not going to do it. Sorry, it took me a moment to figure out what happened with my pen. So I find that it's easier if we get rid of the fraction. So if x over 5 is sine theta, then x is 5 sine theta. And then we take the derivatives on both sides with respect to time. The derivative of 5 sine theta is 5 cosine theta. But theta is not time, so chain rule says we multiply by d theta dt. Similarly, x is not time, so when we take the derivative with respect to time, we get dx dt. So we are interested in dx dt. There is dx dt, which must mean that we must know all of these. Well, 5 is 5. D theta dt we know. So what's cosine theta? Well, that depends. When x equals 3 units, which means that there is a special moment in time when x is 3 units. X is not always 3 units, but there's a special moment in time, a special moment in time when x is 3. And when x is 3, this is 4. And at this special moment in time, at this smit, the cosine of theta is adjacent over hypotenuse is 4/5. And that gives us an answer of 12 units per minute. So that's the basic idea here. We figure out what relates the variables we see. We take derivatives with respect to time. We plug in everybody that we know. Question 2 says that you have the radius of a circle. It's increasing at some constant rate. So if the radius of the circle is increasing at a constant rate, we know that the radius of the circle over time is increasing at a constant rate. We are interested in the rate of increase in the area of the circle when the circumference is 20 meters. So we are interested in the rate of increase of the area of the circle. That's what we're trying to find, which means we need a relationship between the area of a circle and the radius of the circle. And that appears to be this formula. So if that's the formula, then we take the derivative on both sides with respect to time. The derivative of area with respect to time. What's the derivative of this thing? 2 comes down in front. Power decreases by 1. But the radius is not time, so we multiply by dr dt. Chain rule says that's what we've got to do. Chain rule says that's what we've got to do. So we are looking for dA dt. We have dA dt. So what are we interested in? When the circumference is 20 pi. When the circumference is 20 pi. 2 ways to do this. One is to recognize that this is circumference. And if that's circumference, then all of 2 pi r gets replaced by 20 pi. The other way is to figure out what the radius is when the circumference is 20 pi and plug that in, and you end up in the same place. If the circumference is 20 pi, then the diameter is 20, so the radius is 10, and we plug that 10 in right there. We are told that dr dt is 0.2. And so this 20 times 0.2 is 4 pi square meters per second. 4 pi square meters per second. Okay, third one. Railroad track and a road cross at right angles. Here's the track. Here's the road. An observer stands on the road 70 meters south of the crossing, watches an eastbound train moving at 60 meters per second. What's that mean? 60 meters per second. Well, there's this distance. This distance we'll call x because it's a horizontal distance. This distance is increasing at 60 meters per second. dx dt is 60. This is a speed, so it's got to be some sort of derivative. It's a rate of change, so it's got to be some sort of derivative, and it's the rate at which this distance is increasing. X is changing because the train is moving, and it's increasing at 60 meters per second. At how many meters per second is the train moving away from the observer? That's this distance. At how many? So what are we looking for? We're looking for the rate of change of that distance with respect to time 4 seconds after it passes through the intersection. So we ask ourselves, how do those quantities relate? Well, 70 squared plus x squared is d squared. There's no angles here. It's 3 sides of a right triangle, so the Pythagorean theorem applies. What does that mean? Well, this is a number. Its derivative is 0. This is x squared. Its derivative is 2x. But wait a minute. We're taking derivatives with respect to time. So chain rule, derivative of d squared is 2d, but wait a minute, d is not time. Chain rule, the 2's drop. So now we substitute everything we know. What's x? Well, what's x when? 4 seconds after it passes through the intersection. Well, 4 seconds at 60 meters per second means that x is 240 at that time. Again, This is that special moment in time, when the observer is 70 meters south of the intersection and the train has gone 240 meters from the intersection. So Pythagorean theorem says that this is 250 meters, and I'll just let you confirm that with your own Pythagorean theorem calculations. Let's substitute everything we know. dx dt is 60. D is 250 according to this special moment in time. This is the thing we're looking for. So we can get d dt by itself by doing a little bit of algebra, and it turns out that that's your speed. That's the rate of change of the distance of the train from the person 4 seconds after it passes through the intersection. Hopefully this has been a helpful extra for you. Go back through. Make sure you can justify every step in every way. Because these are some of the classics. Right triangles are classics. Circles are classics. Trig is a classic. These are things you want to make sure that you can do on your own. All right. Thank you. Until next time.